I'm Mark Gonzalez, lead cat herder here at MotoIQ, bringing to you PRI, the Performance Racing Industry Show in Indianapolis, Indiana's Convention Center. Really what this show is all about is racing, and just really only that. There's no bro dozers here, Bluetooth drive shafts, none of that crap that we see at SEMA. This is really only racing. Because we are here in Indianapolis, home of the Indy 500, there are a lot of actual race shops around the vicinity of this place. So a lot of those suppliers and manufacturers are right here in these doors. So what we're going to be doing here with the team today, we're going to be choosing a few of our favorite things and showing you around. One of our first stops here is at Wagner.
Actually, it's pronounced Wagler.
But during Mike's stint with JE with his Masters of Motors competition, he actually came up on this diesel engine. It is full billet, and it also revs about 6,500 to 7,000 RPMs. But I'm gonna let Mike, the genius here, kind of give you the roll down of exactly what's going on here. So, kick down, why is this your favorite part?
Well, it's a Duramax, it's not a Cummins. So everybody builds Cummins, everyone knows those make sick power. But here's the Duramax. You know, like it's a V8, so it's shorter, more compact, fit more things. It's probably lighter. I don't know that for sure, but I'm assuming that. So it's a tighter, lighter package. Billet block. Nobody really has put as much into Duramax as the Chevys as this. Mm-hmm. I like the Chevy trucks better, but that's just my preference. I like it because this thing can rev like crazy. Like, whoever heard of a diesel that could rev to $7,000?
How is it that it could actually do that, though? Like, from what I know, power bands on diesels are very, very short. And
well, it's a matter of getting the good port flow, good volumetric efficiency.
Okay.
That's pretty much ignored in diesels. It's getting the proper valve train that can rev that high, and then getting the whole architecture that can take the stress of the super high compression ratio, super high combustion pressures, and the revs on top of all that, because these things have more combustion pressure than just about anything. They produce their own high pressure pump, because your normal high pressure pump for the common rail injection doesn't have close to the amount of displacement that it takes to feed one of these. So they produce their own common rail pump driven off the camshaft. That's super cool. Like a big plenum to set up for forced induction. I don't know, this thing is badass. It makes like 3,000 horsepower and 5,000 foot-pounds of torque. That's insane.
Now, do you know if that's just really meant to be an NA application, or can you even
that's
can you
forced
boost
induction,
this as well?
of course.
Okay.
Yeah. This is designed to be turbocharged.
Meant to be forced induction.
I mean, meant to take big boosts, too. I'm looking at the flanges.
Right, I mean, you just look at the intake manifold, and that thing's like, it's never going to come apart.
I mean, shoot, we should build a prototype and stick this thing in there.
I'd like to know exactly how much this thing weighs too, though, man, because if we're gonna go with that idea,
I bet you it's not as bad as you would think.
Well,
but if it was a prototype, I think this thing could stand being a stress member real easy.
I don't know what the torque output is on this thing too. I mean, just
5,000 foot-pounds.
5,000 foot-pounds of torque.
Yeah, 3,000 horsepower, 7,000 RPM
That's
out of a diesel.
retarded.
It's crazy.
So if you have a few race cars, or maybe your shop that you want to tow, this may be the way to go.
Hey guys, this is Jeff. I'm usually on the other side of the camera, so you get to see me now. And Eric.
Hi, how's it going?
Editor, he's the owner of our Project SC300.
Yes, yes.
And we're here at Pfitzner, or PPG, and we're here with both of our favorite picks.
Yeah.
If you want to start?
Yeah, so
talk about what we got here.
Yeah, we just did that Grannis Racing T56 swap on Project SC300, and the T56 is a great transmission. It holds a ton of torque, way overkill for all the power that we're putting in, or for the little bit of power that we're putting into our ST2 car. But everybody likes straight cut gears, helical gears. They like to flat shift and bank shift, and so this gear set upgrade for the T56s is really cool. It'd certainly be something I'd love for them to let me put in the car. But and then you kind of were looking at something else that you thought was even cooler.
Definitely. If you want to come over around here, camera. So here we have PPG's sequential 6-speed transmission that they've made out of a T56 Magnum. So this uses the exact same case as a T56 Magnum, but they've changed all the guts inside, so it's sequential. You can get it with the little box here that allows for blip shifting and no lift to shift. So you don't have to use a Motec or anything else. This will just piggyback onto your existing ECU.
It has dog engagement, no synchros, so you can shift super fast. It has helical gears, so it runs quieter than your normal straight cut gear race transmission. What I kind of don't get is you have helical gears, and that has like more frictional losses, right? But then you have like dog shifting. So why do you have those two together?
I don't know. We should ask them.
You got dogs. Why go with helical? Why not just go all the way with?
Because a lot of these gears are so wide that actually when you go helical, you actually increase the surface area. Now, if it was a really thin gear, then a straight cut would be optimal because it's optimal strength. But because the gear is so wide, we can actually go a slight helical angle and gain, in reality, more contact area and more strength. Sometimes people who say that straight cut's stronger, the reason why they say it is because they don't make helical. So it's a bit of a misleading thing. So these are exceedingly strong because they're really wide. So this reduces cabin noise. So when you have a road car, cabin noise can be an issue. If you're driving on the highway and you're cruising in sixth to somewhere, you don't want to be screaming in the cabin because it becomes uncomfortable. And a lot of these cars, they drive every day. You know, they will do the daily drive, or they will go fetch McDonald's or go to the shops, you know. So this is a balance. So the helical keeps the noise sensible, but it's also very, very strong. And indeed, this beautiful ACR Viper has helical gears inside. And same on the Synchro set, helical gears once more. Where the profile's thinner in profile and it's more compact, straight cut's optimal, just because it is in that smaller application stronger. But sometimes there's a lot of misleading, you know, assumptions on gears, but that is actually the reality. So helical for us, yeah, we like to do it because it's pretty robust.
And you've done your research, you know.
Yeah. History tells us we know this. I mean, this gearbox here is doing 2,500 horsepower in the Viper. So, but that's impressive enough. But when you say it's like 2,300 foot-pound of torque, that's even more impressive from a 9-litre twin turbo. So, you know, it does the job, but it keeps it sensible in terms of cabin noise, and you know, that's why.
Awesome. Well, thanks again. I appreciate the explanation.
Thank you.
Cool stuff from PPG.
Engine number 2, and one of our favorite things that we've seen here at PRI this year. Honestly, I kind of thought it was a sideways four-banger at first, but then noticed that the head was off. Mike is Mike's choice, so another one of Mike's favorites. So you let us know why you like this, man.
Well, this is a clean sheet of paper motor from Jesel, and it's almost like, well, what it is a pushrod motor with no compromises. It's not based on any kind of OEM architecture. It's a clean sheet of paper design. So there's no compromises in the design. Basically, like what limits a lot of the V8s is like maybe something like bore space, and you can't get the kind of bore you want. Like the port geometry is compromised to make room for pushrod tunnels and stuff like that. Well, this engine, it has like a wide bore spacing, so you can run just about any kind of reasonable bore in here. The crankshaft has like wider counterweights that are smaller, so the inertia is less, and there's less windage losses. The crankcase is partitioned like an F1 car, so you don't have pumping losses in between the bays, so the air is just going like this. Each bay of the crankcase has its own dry sump stage. The dry sump is integrated into the block and pan, so it's really clean, just like an F1 or an Indy engine.
And like you said, it's from a clean sheet of paper, so it was designed to do it. So there is zero compromises. Now, is that also a reason why, for example, when we're looking at the head on this side, like things are not exactly completely symmetrical?
Yes. Well, what it is they want to get everything in line. Like you can see how the lifters bores are staggered. It's that's so they could get the push rods. The push rods will push straight on the rocker arm, so there's no angularity losses and no changing in the motion ratio as things go up and down. So it's a straight shot. Everything could be a little bit smaller, so there's less inertia. You notice the camshaft is really high in the block, like probably 2 inches higher than your normal V8. But that's so the push rods can be super short, and that way the reciprocating weight is kept really low. You can see that the rocker arms aren't huge, they're small, less inertia. Push rod pushes straight at it, so there's no angularity losses. Everything pushes straight, so there's less side load on the valves. The valves are canted and tilted, so the included valve angle is really good, so you get a really good shot into the combustion chamber, and a really good exit from the exhaust valve. Like no compromises. A really cool thing is the spring seats are beryllium copper. Valve springs get really hot, so this pulls heat out of the valve spring. The other cool thing is that the seat is threaded with like some lock bolts. So when you set your installed height, instead of using shims and trial and error, you just loosen this, you get a spanner, and you screw your installed height into place, so it saves a lot of time. That's a pretty clever feature. This thing is just full of crazy cool features, like everything dumb about a V8 that pissed you off, this thing's addressed. Right back here, there's a scavenge pump that's driven off the cam, and like a lot of times all the drain back oil pours on the cam and that pours on the crank, so that creates a big part of the windage cloud, even if it's a dry sump motor. Whereas the scavenge pump back here that evacuates all the oil out of the lifter valley, so none of that pours onto the crank, so your windage is really controlled on this motor. Some other cool things in the front is, you notice how short the snout is and how close all the accessory drives are to the end of the crank. This is so you don't have that long snout and your accessory drives putting a bending load on the thing. And
it's kind of like the leverage effect.
Yeah.
The further out it is, that's the more pressure you're putting on something.
Right, and this is all, like in there, so there's no leverage for that to tweak. There's so many cool things. It's like unimaginable.
And even look, this is for the coolant. I'm
yeah,
assuming,
it's like
right?
a
It's
Dash
already
20 hose.
Yeah.
But Jesel even developed their own fittings. Like this isn't AN. Like AN is fine thread and it has a 45-degree seat. Mm-hmm. This is a steeper seat, coarser thread, and like how sometimes you try to get an AN fitting started, it's almost like cross-threading because of the fine-tooth things. So this thing, you just like slap the thing in, give it some twists, it gets started. You get your fittings on and off real quick. You notice all the head bolts, it's 4 discrete head bolts per cylinder, so there's real even clamping pressure. And the coolest thing is these tower bolts, the head bolts, have Torrington bearings on them. So almost all your tightening force is going into actually stretching the fastener, not friction between the bolt head and the aluminum.
Which means you're going to get a more even head seal, really.
Right. And more accurate torque readings, and you're going to get every bit into the stretch. More coolness is on this side. So what you're looking at here is a variable displacement oil pump. You set your pressure. This is the reference for the pump off of the cam galley. Goes in there, and there's like a swash plate. And so you set your pressure, the swash plate moves, sets your volume, and no matter what, this is the reference, you get the same oil pressure no matter what the RPM is. So you don't get excessive pumping, excessive windage. You don't get a shitload of oil at idle and at low RPMs. It's just the right amount of oil, so your windage is really controlled.
So maximum power and maximum protection without giving up on either end of that.
Right. And this thing is so full of cool stuff, I could keep going. I mean, you look at the camshaft, the lobes on this are 3 times bigger than your normal camshaft. What that does is it gives you more room, so you can get a more accurate grind. Like some of the things about roller cams is you need to have like an inverted flank so you get the normal valve motion, because it's not like a lifter that's going like this and then like that. It's a roller, so you get this weird peaky lift curve. So you need like an inverted flank, but when you have a tiny little lobe, your angularity is changing and it's hard to get good valve train stability. So this thing has huge lobes, and a huge roller. The other cool thing is the lobe is narrow, you might notice, and the guide for the roller follower is actually built into the follower itself, and it goes on either side of the lobe that holds the wheel, like, so there's no way that the roller lifter can skid sideways or anything. You don't need guide plates and all that weird stuff. It's all integrated into the design. Plus the diameter is huge, so you have like a lot of bearing area, and it's DLC coated, so the DLC reduces friction, and the big diameter reduces side load. That's super cool. So the final thing that's cool about this engine is the block's modular. So let's say you throw a rod and you window your block. Well, this expensive billet block isn't trash. You could just take out the side piece, replace that bay that was damaged when the rod got thrown, and you're back in business without having to get a whole new billet block.
Now, speaking of your block is not thrash, how much is this thing?
I don't even know. It's not really in production yet, so it's something that's really new, so that's yet to be seen. I mean, the other thing you can look at it is look how compact this is.
No, absolutely. Like if you guys come over here and get a profile shot of just the entire front, you can see really just how much real estate this would take up in an engine bay, and it really is not very much. And one of the last things, I mean, just like Mike was stating, that this is really an amazing engine and a total just brand new build, so much so that it won the Masters of Motors, correct?
Right, it won the Masters of Motors. This is an all-clean architecture block. It's not a Chevy, it's not a Ford, it's not a Chrysler, it's a Jesel. And like what I was saying, there's no compromise in. This is the ultimate pushrod motor probably ever built, I would say.
All right, yeah, I ain't got anything to say. But what we will do, we will try to get a price for you, so check the comments and see if when we update that. All right, well, here we are at Safecraft. This is one of my personal favorite picks. All right, I know it's a Chevy Sonic, but wait just a sec before you judge me too much. This thing has an LS in it, and it's also all-wheel drive. It is a full race car build. We actually have also the owner and builder of the vehicle, Pat, here, and he's going to kind of walk us down and give us a couple more details. Hi, Pat. How you doing?
Hey, how
Sorry
you doing?
for checking you out there. So maybe give us some details on exactly what kind of an LS is that we got here.
Okay, so what we have is just a regular stock LS3. It's actually detuned a little bit because when you get these cars on the stage road, you really don't need as much power as you can get out of a bulletproof LS3. So the idea and the concept behind this whole deal was to put an LS3 into a reliable, durable engine into a rally car, so that you don't have the problems that we always run into in rally where the turbocharged cars, if one little thing goes wrong, you're replacing head gaskets, you're knocking bearings out or anything like that. So reliability, LS3 probably outlasts the body of the shell, and that's just the greatest part about it, right?
It's much like the drift programs that you see and how a lot of folks have moved over to LS platforms. You don't have to run four-cylinder engines that are running to the ragged edge. You generally have a wide power band without really the necessity or complexity of the turbo systems. Now, this is also all-wheel drive, correct?
It is.
Now, I know the Sonic isn't an all-wheel drive vehicle.
No, it's not. So we did the all-wheel drive, we did the Rallycross program for Chevrolet, and obviously with the defunct of the Rallycross thing, had some extra parts left over, so we actually have a 6-speed sequential gearbox in the car, flat shift, and then the diffs are in the front. Axles are not in the car right now, so we can push it in and not tear up all the carpet for the show. But another thing that's really spectacular about this car is that it has 12 inches of travel. So it has long travel suspension on the car, all of the fun stuff that you need to have in a rally car. So in the way this works in the American Rally Association, there's a little bit of a rule that's been in rally for about 73 that you can go up to a 6.3 liter engine, normally aspirated,
without really any big limitations.
You still meet the same requirements as an open car. Some Dodge engineers did it back somewhere in, I think, the mid 80s or something like that for a short little run. And just looking and reading through a rule book, you look, boy, this just sounds so right.
What's stopping us here?
Yeah, what is stopping us from doing this? So some of the GM guys were here, looked at it, and we knew them from before, but we didn't really pull this out because we wanted to make sure that it was kind of a not a lot of people knew about it until it got unveiled. So,
All right. Now, what I'm seeing here, obviously this is custom work.
Absolutely.
Increasing the travel of the suspension.
Yeah.
Now, on the underside, do we have also custom control arms? Or,
Absolutely.
So
Yeah.
geometry completely changed as well?
yeah, absolutely. To account for the long travel, the geometry has to change and all of that kind of stuff. So we modify it within the rules. So the stock firewall and the stock floor plan still has to stay in the car. But so what we do is we've solid mounted the engine. The subframe comes up and mounts on the bottom. So if we have to change a subframe for damage or any of that kind of stuff, it can come up through. We use a great product here called Docol that's been supplied and located here at the PRI show. So that subframe can be easily changed. The front diff can be easily changed. Everything is basically doesn't attach to the other part, so that you can change other control parts.
This is an amazing build, man. It really is,
Yeah,
from
thank
top to bottom. Now, as far as how did you get the all-wheel drive drivetrain into this thing now? Are you using parts from maybe another chassis or?
No. This is all motorsports components. So again, it comes from the GRC program where
Okay.
we had the motorsports transmission. So it's a Mack-Track transmission that's used in rallycross. The diffs are all motorsport diffs. So basically it's a lot of time on a computer, put it in CAD drawings, make sure that it all works. Special made axles. The control arms are all really nice, billet control arms, uprights. The bearings in it are oversized bearings. So everything on this thing is really built for durability.
Okay. Now, Pat, what was the name of your performance?
PMR
shop?
Motorsports.
PMR Motorsports, and that's
Yeah.
who designed and built and put this vehicle together,
Yep.
correct? And there you have it, guys. This is actually one of my favorite pieces here. I would love to get behind the wheel of one of these things, but probably won't happen. But one can dream.
Probably work that out.
You heard it here. Here at Tilton Engineering with one of Eric Jacobs' picks with this sliding pedal setup from Tilton. He's going to go over some of the features and why we all here actually think it's pretty cool.
So if you remember from Project SE300, we recently added the Tilton 7.25-inch clutch setup and their flywheel and a bunch of their other products to our project. And so I came by and saw this really cool pedal assembly. The interesting thing about this pedal assembly, two main features. One, it's the first Tilton undermount, floor mount pedal assembly where the master cylinders are actually under the pedals. It makes the whole assembly much more compact so it can fit in more applications in a floor mounted orientation. The other really cool thing is that it actually has a slider.
You don't even need to push it. We could just pull this. You can even let go of that. And as soon as you pull it, you can see that the whole thing slides forward.
Oh, it has pneumatic cylinders.
Exactly.
And so this is a really neat feature for cars
pull
that
back.
feature multiple drivers, especially in endurance type racing where you're making driver changes a lot. You can still use a fixed seat setup and get away from those hacky-janky seat sliders, but still be able to accommodate different driver sizes on the pedals. Why does this have a full kind of spherical bearing as opposed to maybe just a radial bearing?
Well, one of the things is if you rigidly mount the master cylinders in the pedal box frame, when you turn the brake bias adjuster here, you can see how the fulcrum moves as you're adjusting the brake bias. So the cylinders are tilting from side to side. When you have a spherical bearing here, the whole master cylinder assembly can actually tilt with the balance bar. And if it was rigidly mounted, you'd actually be moving the rod and the piston independent of the housing. So you have side load and you're tweaking the piston and the bore and you could have leakage and stuff. This thing moves the whole thing so everything stays in line, no binding, no potential for leakage. It's super awesome to have it like that.
And to have your slider here, I mean, it really is a lot safer when you're doing your seat mounts. Like, you don't have to have a sliding system for your seat. You can actually have a fully rigidly mounted seat, and your adjustments you're going to make here, and possibly if you have a telescoping steering wheel, you really have, anybody can jump in the car and do it. Actually, you were talking about the Team America car, right?
Right, like on the Team America car, like if I'm going to drive it, it takes like about at least a half hour to move the pedal box, so my short legs could do it.
So you have to unbolt the pedal box, move it over.
Yeah, and undo the line brackets and all that, and the air gets grumpy.
That's a headache and a half, though.
Plus you got to like cram your body into the footwell, and you're working with these little small Allen bolts, and that really sucks.
Especially considering these things are on the driver's side. Most of us know that if you have a race car, you're gonna have all your bars, your safety bars there. So getting into that area of your car it's not exactly easy. Now you can remote mount this lever here anywhere in your car, along even with your brake bias adjuster. You don't have to dig in anywhere. Makes it easy.
The final thing that's cool is if your seat's mounted in the same place, you're just moving this. You change drivers and all that with different leg lengths and all that. You keep the big heavy driver in the same position. The car's corner weights and all that stay more consistent.
Oh, dude, I didn't even think about it. That's a very good point, man.
So your setup stays more consistent, and it can actually make a pretty big difference, like up to 1% of like your cross weight and all that by moving the driver that much. If you have a fat ass driver like me,
like us earlier drivers.
Yeah, you'll see it in the corner scales pretty significantly. So being able to keep the driver in the same place, pretty big advantage.
So if you guys are building a race car, this is something you should definitely look into, especially endurance racing where you have multiple drivers. This is the way to go. Thumbs up from us. Here at the JE booth, we're going to talk about some pistons and basically the new forging process that JE is implementing in all of their new piston manufacturing. Mike, why don't you drop some knowledge on this?
So JE's new forging process is called the Ultra process. Now what this does is it aligns the grain of the metal with the geometry of the piston. So the grain of metal is kind of like wood, and it acts very much like wood. So when you're with the grain, it's real strong, real ductile, and when you're against the grain, it can get more brittle. Now there's like various different forged things, like Vogue Wheels aligns the grain of the wheel with the geometry of the part. Now in the past, when you typically get a forged piston, the forging is a big long piece. They kind of saw off a hunk and machine the piston out of that. So the grain's kind of just going straight up and down. Now what JE's doing in the Ultra process is to use a sophisticated multi-stage die where they kind of hit the blank time and time again and progressively smash the piston into its close to net shape. So this gets the grain, like aligns it around the pin boss, through the skirt, kind of in the direction of the stress. So instead of the grain being like this, with your pin boss in there like that, where it can just bust through, the grain's kind of going around.
That makes sense.
Yep. So the grain's aligned in the direction of the stress. It's a lot stronger. The forging blank is near net shape. Once it's done going through the progressive dies, then they finally machine into the final shape. So to do a quick demonstration, like here's a piece of wood with the grain kind of, I guess,
not aligned or just
not aligned.
Scattered.
So you can just go like this. You see how easy that breaks? Now you get the grain that's aligned in the correct orientation for the part. It's, damn, it actually makes, it's really strong. The new improved wood dome piston from JE.
Yeah, dude, that ain't going nowhere. So you're saying that if I were to put this way, it'll break easy though, right?
Yeah, if you try to bust it with the grain.
Absolutely.
Yeah, it's a big difference. The new forging method for JE, really cool stuff. A lot more strength, doesn't affect the weight, and that's all new.
Here at Comp Camps now, as you guys know, we have a lot of expertise at MotoIQ and our MotoIQ garage building LS engines. Being in charge of Dai Yoshihara's drift program, we've gone through a lot of trial and error, and we pretty much perfected these things. And Mike has basically seen almost every failure that you could possibly come up with. Now, what we're going to look at here is new Comp Cam's new shaft rocker system. Mike, what's up?
Well, one of the things about a drift car is when it hits the rev limiter, it really violently bounces and the RPM's fluctuating really close to the valve float limit of the engine. And when it's fluctuating and hammering like that, it could actually contribute to the valve float. Like where the rocker arm's actually skipping off the top of the valve. Mm-hmm. Now this is a stock LS rocker, and it kind of pivots on a bolt that goes and bolts this down to the head. So what we see in the drift cars a lot is it starts getting a float on the rev limiter, and this actually skids off the valve tip. When it skids off the valve tip, it hits the retainer, knocks the keepers out, drops the valve, the whole engine blows up.
Because on a stock setup, these things are alone with no bar going through it, correct? So
Right.
that's why when it floats, it could go left or
Like
right.
it could pivot around, and I see that kind of failure like a lot on drift cars. Not just LS, but almost anything with rocker arms
Okay.
and stock. So in the past, what we've done to fix that is we get what's called shaft rockers. So it's a roller rocker like this, where it has needle bearings and it's mounted on the shaft. And that's super expensive. I mean, you could spend like $2,000 just on your shaft.
Just on the rockers.
Yeah, just on the rockers alone. So you look at your grassroots guys, it's out of their budget. It adds a lot of money to their engine build, and they end up, like skipping that step, trying to make do with this stuff. But, a simple thing, bumping the rev limiter, leaving it on there too long, this slips off, hits the retainer, knocks the keepers out, valve drops, their whole engine blows up. So, like by trying to save a few $1,000s, they end up blowing the whole motor.
Yep.
So what CompCams has done is they come up with a solution where you can have the stability of a shaft rocker, but with the economy of the stock rocker. So what you do is you take out the stock trunnion, press it out, and you can use the stock rocker body on the shaft with the roller bearings and everything in there. And this thing costs about $700 versus $3,000. And you get a lot of the advantages of the shaft rocker. That can't spin or go nowhere for like a fraction of the cost, like a quarter of the cost about. One of the other things we see a lot with the drift motors is when you run valve springs that are stiff enough to not go in the float. On the LS, the mounting stud here actually starts to flex, and it actually cracks the head like right in the intake port. Cracks, you get a huge vacuum leak, everything goes to hell. So on the Pro motors, we go to these shaft rockers, so the force of holding everything down is spread out through all of these, so you're not like killing on each individual stud so much. So this gives you the ability to spread it out like that, use the shaft, and it doesn't cost nearly as much as your typical shaft rocker setup. This is a new product from CompCams. I think this is almost like a game changer for budget motors.
So these are, again, the stock pieces. These are the stock roller rockers, and you're just literally adding the bar in. You're pressing it out, adding this, and you're good to go.
Yep.
It seems like pretty much a no-brainer almost if you're building a high-revving LS engine.
I would almost use these unless it's like a really mild motor or something. So even in the street build, I would do that just for safety.
All right. So look for these things for your LS builds on CompCams.
Cool stuff.
All right, now our next stop here is Turbosmart. This is one of my favorite picks here for the PRI show. Granted that this actually did come out for SEMA 2018 as well, and Turbosmart won plenty of awards there. This is their new anti-lag valve. They're not inventing anything new here. This is already technology that's existed. Anti-lag is nothing new. But that's stuff that's been pretty far-fetched from the average guy. I mean, this is proprietary information from race teams like guys that race in ALMS, IMSA Racing, even a lot of rally car racing. Everybody, all those teams, this is proprietary information. Turbosmart's come up with a solution that you can have a fresh air anti-lag system and plumb it pretty easily into your vehicle. Now, maybe we're going to get here in the mic and he's going to give us a little more tech information. This is exactly how it is that we can plumb this into your turbo system.
So one of the things with anti-lag systems in the past is you have to do elaborate things like have throttle kickers. You have to have change the mapping in the ECU, so when you let off the throttle, the ECU goes really retarded with a spark and really rich. The retarded spark is so the engine won't make torque. And then you're combusting hot gas to keep the turbo reeled up. All that's really hard on the exhaust valve, really hard on the turbo, really hard on the exhaust system, the manifold. Puts a lot of heat in the engine compartment. So it gets rid of lag to a large degree, but hurts reliability. So what's innovative about this system is this kind of takes the place of your blow-off valve. So when you lift the throttle, the throttle closes and your boost pressure that normally backs up and causes surge or gets dumped with your blow-off valve just gets rerouted back into your exhaust system, and the added gas volume helps keep the turbo spooled. So everything, turbo keeps spooled, everything stays cooler, it doesn't have the thermal shock, it doesn't heat up your whole engine compartment and exhaust system. So it's not quite as effective as having the really elaborate anti-lag, but it doesn't hurt your reliability one bit. It's making use of air that could cause surge, and it's giving the gas volume to keep the turbo going. It's a really cool idea.
And honestly, guys, I mean, obviously the fad nowadays is to have those bang bangs, that pop and that fire coming out of your exhaust system. That's all fine and dandy, and many tuners can tell you that, yeah, I can tune your car to do that, but that is really a violent situation you're creating, and you're really going to hurt a lot of parts in your car. If you're going to do it right, this is only about $300 from Turbosmart, and you can have a true anti-lag system.
That's not going to hurt your reliability at all.
Absolutely. So be sure to check it out, turbosmart.com. So right behind the anti-lag valve, we kind of looked behind us and saw this monstrosity of a motor. And it is a Hemi, but it's 5,000 horsepower. Actually, beyond 5,000 horsepower. So this thing is intense. Marty, give me a little bit more detail on what's going on here.
Proline Racing Engines is one of our partner companies, if you want to call it that. If you order a Proline Racing package for your program, first of all, it means you're serious and you want to win, and they're the guys to go to. And they spec Turbosmart products in on all of their racing combinations. So we've worked with them, and they love our products, and they do the job for them. And I think it's working together with really high-quality companies like that. I mean, our goal is to help people win and be happy and break records, so that works. This engine is one of their 520-inch Hemi combinations that they've developed. They've spent a lot of years developing these engine programs to where, I'm not kidding, I remember, back in the more early days of turbo drag racing, and I'd be at the track, and the guys would do a run, and they get back, and they're changing rod bearings and doing things like a top fuel car would. And these days, because these engine packages have become so refined and so proven, they've really got their recipe down. I mean, they barely take the valve covers off. After a run, they'll check the spark plugs, they'll look at the data, in the system, and work on the chassis and go out and run it again. It is amazing how reliable these cars are, and literally, they'll make almost as much power as you really want to. It's just a matter of getting it down the track. They'll leave the starting line at virtually no boost, and they progressively bring in the boost and the power as traction will allow them. They use boost control by G's, boost control by RP. I mean, a lot of really sophisticated ways of applying that power. So they'll leave the line at very low boost and cross the finish line at that quarter mile with 70, 80 pounds of boost. So they go from zero to that, and they're just applying the power as they can and get it down the track.
Boost.
Yeah, it's really amazing. And we've worked really hard to develop, especially our compressed gas wastegates, to help allow them to do that, and it's gone very well.
So there you go again, just more proof that Turbosmart helping more people go fast reliably.
I'm here with Jeff at Canton Racing Products, and this is one of my picks, this 2-quart expansion tank, and it has an integrated recovery tank. I know what the two are, but I don't really know the difference, and what makes it so cool that they're together.
So essentially, if you don't have a high point in your coolant system, you need to use an expansion tank. This also integrates a recovery tank, so once everything heats up, it gives a place for the coolant to go. Once it cools down, pulls it back into the expansion tank.
Okay, so it's pretty specific to if you need or if you lack a high point in your...
Yes.
Okay, very cool. And I assume this helps save a lot of space in the engine bay because it's all together.
A lot of custom builds will require one of these tanks. The lower your radiator, obviously, the lower your fill point's going to be. Sometimes if they even have a fill point on the radiator, so the expansion tank kind of bypasses that problem.
Okay, and if someone picks up one of these tanks from you, what does it come with? They got to buy different fittings and all that, or?
Basically, they just need to pick up the fittings to run it, but it will come with the sight tube, the caps, and you just need mounting hardware.
Awesome. There you have it. Thanks for your time.
Yeah, thanks, Ian.
Canton Racing Products 2-quart expansion tank with an integrated recovery tank.
So while not exactly automotive specific, this is my second choice for favorite things I've seen at PRI so far. This is Miller's new Multimatic 220 AC/DC welder. It'll do MIG welding, it'll do TIG welding, it'll do stick welding too, I believe. This can replace, we got a Syncrowave 250, I think, at our shop. I know I have a Millermatic 200 MIG welder. Giant machines. This thing can replace them all and pretty much do everything those machines can do, and obviously a lot smaller package. You can take this thing, you can hook it up to both 110 wall plug power in your house, or hook it up to 220 in your shop. You can hook up 2 bottles at the same time, so you can have your argon for TIG and your CO2 gas for MIG hooked up at the same time. Say you're welding like putting together a roll cage. You can be tacking everything together with your MIG welder, and then come back and TIG with it without doing anything, without changing anything at all. And all you have to do, if you come up and look here real quick, say you're tacking with your MIG welder, you just hit the gun here, and you can see the MIG mode here. Then, if you pick up your TIG torch, you hit the pedal, and then you can see on the display, it goes into TIG mode. So you don't have to do anything. You don't have to mess with knobs. And then this thing takes out a lot of the thinking you've got to do when you're welding. It's got an automatic feature, so you can just set what you're going to do, pick your thing, so say we're going to do TIG, give it a second here, and it shows you exactly where your plugs need to be, so it shows you everything you need to do. You just dial in the material thickness over here, you can increase that. It goes all the way down, I think it's like 22 gauge. It goes from 22 gauge all the way up to 1/8 inch for TIGging aluminum. Then it automatically sets your sweet spot for your amps. You tell it what tungsten you want to use, and then if you want to fine tune it. But literally everything on here is set up, so you just like turn it on, and it's so easy to go. And I'll probably still not be able to TIG weld with it, but it's going to take away a lot of the work that you'd normally have to like flip switches and stuff to figure out on like this welder like we got now. Anyway, that's my second pick. I love this thing. I think I'm going to try and sell my other welders and buy one of these. Oh, and it's less than $3,000. I think it's like the show price is like $2,800, and it's like $2,900 regularly. So it's a great deal. So we're at Radium Engineering now for one of Ian's picks. Ian, what are we doing here?
Well, everybody knows that they make full-on fuel systems and surge tanks that you put into race cars. But for those of us that don't own race cars, they have the perfect street setup. Over here, they have basically drop-in OEM location surge tanks that require no permanent modifications, no drilling, no tapping, and, they're hidden. So I think that's really cool. And I see a application that fits you.
Yeah, it's an RX-7. So this obviously drops right in.
Yeah, this plastic part's actually from it's OE from the car.
This is the tray?
Yeah, so they have this out here to show that, it fits in without any modifications. So
what about fuel level sensors? Is that in here too? Do we have a Pro?
Let's get the Pro in.
Doctor?
Oh, yes, sir.
What about a fuel level sensor? Is that included in here?
No, it reuses the OEM sensor.
Okay. So you have to.
It's transferred from your stock unit to it bolts on right there.
Oh, okay. So it's already ready. You don't need to measure where it needs to go.
It's already set.
Okay, so this probably isn't smog legal, so it's going to kick me out of that.
Well, good thing your car is a race car only for off-road use only in California.
And I never drive it.
And you never drive it. But it looks like they got applications for current Imprezas, FRS, BRZ, Toyota Supra, and Aaron over at Radium just told us that they just bought a 370Z, so I'm sure there'll be a drop-in kit for that as well coming soon.
Cool stuff from Radium.
So I was a judge in the Masters of Motors contest, and this is one of the cars I picked to be one of the winners. And I was really impressed with the car, the build, and the motor. And so you're the driver, Nikki, right?
Yes.
You want to tell us a little bit about the car and what its accomplishments have been?
Yep. So it's the Toyota GT86, and we've swapped out the engine for a 1FZ Land Cruiser motor, and we've put the 98mm turbocharger on it, and we've also got the Mickey Thompson radial tyres under the rear end, and currently we're the world's fastest import radial car with a personal best of 655 at 219 mile per hour.
So that's with DOT radials, huh?
Yes, that's correct.
Pretty impressive.
Yep.
So what impressed me too is that your typical engine swap is the 2JZ, and like everybody does that. You want to explain the differences between the 2JZ and this motor that we don't have in our market?
Yep. So basically we chose the one I've said because it's not a 2J and it's still a Toyota. They come out standard as a 4.5 litre and we've de-stroked it to a 3.9 litre. And yeah, it's just basically a bigger and better version of what a 2J is, and we're only at the beginning stages of the power that it's capable of.
So when you de-stroked it, you have the tall deck height of this motor, and you probably have a really long rod to control piston speed and stuff?
That's these guys.
Oh, okay. How much power does this engine make?
We expect it's making about 24 to 2,500 horsepower at the engine. We've had it on our mainline hub dyno, and we've seen over 2,000 horsepower on boost levels around about 70 to 80 psi. So,
at what RPM do you make that power?
Look, we've dyno tested it to about 9,500. We're seeing about 10,000 RPM at the track. It seems to be really sort of where it's working well at the moment with the camshafts we're using and the turbo efficiency. It's working really well.
What turbo are you running?
Presently we're using the Garrett Gen 2 98. It's sort of working at about its peak limit at the moment. We are going to endeavour to probably move on to a larger turbocharger now that we've sort of got that one in place and working really well.
I mean, we have an 8-liter drift car, and I think our turbo is still smaller than that.
Yeah, well, most of the power is designed for the upper RPM. I mean, most of the power band's probably between 8,500 to 10,000. So
I see you have a lot of injectors there. Are you running methanol?
Yeah, we are running methanol as a primary fuel. We've got 18 injectors, 3 per cylinder, and we've actually got another 2 that aid in the cooling on the intake pipe. So 20 injectors all total.
Mm-hmm.
Yeah.
So you have some post-compressor injectors before you even get to the plenum.
Yeah, we do. We've just sort of tested that. The car's non-intercooled at the moment. With the boost levels we're using, it seems to be okay. And they just aid in a little bit more cooling to the charge.
That's pretty impressive. So what's your bore and stroke on this?
It's just over 100 mil bore, and it's an 82 mil stroke.
That's a short stroke and a big bore.
Yeah, it's a very short stroke and big bore. It gives us a lot of room in the chamber for some big valves, and also gives us the high RPM.
And you're running a real long connecting rod probably with that high deck height?
Yeah, well, because it was originally a 4.5 litre engine, and I think they're a 95 millimetre stroke factory, we're shortening it up. We were allowed to change a few things around and get it away from the design of the engine, which was originally a commercial use engine, and turn it into a bit more of a racing type of engine.
What's your stroke to rod length ratio on it?
To be honest, I'm not 100% sure on that one.
Do you know your rod length?
Yeah, I do, but we like to keep that one a little bit
secret. Okay. Because I think some of the advantage of running the tall deck and de-stroking it,
correct,
you probably get a real good rod ratio, so you can get a really good VE at high RPM.
Yeah, that's right. I mean, we've worked on those sort of things and to try and produce the best possible combination there.
It's a very impressive engine, and that's how it got my vote.
Yeah.
I guess we're going to check out the some of the electronics.
Yeah, we'll pop.
So you want to tell us about the electronic package you're running?
So we're running 2 Link Extreme ECUs now. That gives us peak and hold injectors control for 18 at the moment, 2 in the pipe. We've also got the provision for another 6 to give us 4 injectors per cylinder. Now, we've split the ECUs. One does predominantly the engine controls. The other computer does all of our transmission and chassis control.
Oh, okay.
Now, all that data combined with the MoTech PDM that's in the car, it's all sent over to the MoTech dash and logged there. So we can view all the data over there in one place and individually in both the ECUs.
Now, as far as electronic transmission control, I mean, I could see that you have a trans brake probably.
Yes.
And does the ECU control the shifting also?
So the ECU controls the trans brake and bump function. So it gives us complete control over that shift function, and also the controls of the converter
Oh,
through
so it's
on the
like a
transmission as well.
It's a lock type converter, and you can lock up the converter at high RPM.
No. That's more start line type control and power management.
Oh, okay. So
so it's a
power
non-lockup.
management. Okay.
Yeah. So.
Yeah, that's pretty trick. Why did you use the Link ECU?
We've been using the Link product for a very long time now. It's reliable. It always works for us, and we know we can pretty much do anything with it. So the Link gives you the ability to create a map and condition it any way you want. You're not locked down.
How about wiring? You have all the good Raychem stuff and all that?
Yeah, it's all Tefcell, wire, Raychem, concentric twisted, all mil-spec connectors and boots throughout the whole car. You won't really see any exposed wire.
And that's another thing I noticed when I was one of the judges for Masters of Motors, like the clean wiring and all that. And one of the things that caught my eye, because for MotoIQ, I always preach to our readers that you got to spend extra money in the wiring and the plumbing, because in my experience being in motorsports, like probably about 80% of your failures are due to the wiring or the plumbing messing up.
Correct. You lose a race or you lose testing passes because something doesn't work. So you wire it correctly and you use a good product, and you don't have that problem.
A lot of people put a lot of money in the engine and the drivetrain, and they skimp out on the wiring, and that's just nothing but problems.
Correct. So incorrect wiring will potentially blow your engine. Your engine won't wreck your wiring. So.
Well, I've been super impressed with this car. When you're at a show and judging, like a lot of people bring stuff just for show. Maybe a lot of it hasn't even been proven and it doesn't even work. But what's impressive is your car's so well turned out, and it actually does something. It actually kicks some ass.
Yeah, well, definitely all the functions we've intended to put into the car work and are proven. So.
Yeah, I mean, looks great, and it's a winner. What more can you say?
Yeah, you just keep moving forward with it. So.
Well, thank you very much to the whole team. It's great interviewing you. It's a pleasure to judge your car, and one of the most impressive pieces here at the show. Thank you.
Thank you very much.
A little more bonus coverage here at the Neo Motorsports booth to take a look at this, what I originally thought was a Geo Metro, but it's actually a Suzuki Swift. But when we take a look at what's in here, it is a K20 powered Suzuki Swift. This thing only weighs 1,700 pounds, man. So, I mean, just imagine 450 horsepower to the wheel at only 1,700 pounds. This is an awesome car. So we're gonna kind of try to give you a little look around, a little close-up look at what really is under the cover of this car, man. What do you think, Mike?
I think it's pretty cool. I mean, it's a simple car, but it's pretty well turned out. I mean, it has a lot of details. Like I see it has an AccuSump, a real fire system, Tilton pedal box, billet raised shifter, a fuel cell. It's pretty turned out and pretty complete. Yeah. Like a lot of grassroots cars are missing like most of those things.
Mm-hmm. And this thing is really putting the hurt on in the Canadian time attack scene. And
I guess another thing that's unique is that this car has just about all composite body, and that saves a lot of weight. Mm-hmm. That's really cool.
Agreed. I mean, not granted that I guess the car doesn't really need to go on that much of a diet, but considering it's already a very light car.
Well, I mean, that probably helped the car achieve the really low weight.
Yep, agreed. And I guess they really could use any more air that you can use, the more downforce, the better. As you can see, also is running this new Nankang tire, 245, correct? Why don't we bring in the owner? Come on in, man. Give us a little introduction.
Hi. Yep. Kevin Stittle from Toronto, Ontario, Canada, and the owner and builder of the K-Swift.
So what?
How did this happen?
Yeah,
Why?
Like,
what's going on?
Why? Yeah, exactly.
Pretty easy. Kind of inherited a Geo Metro from my father as my first teenage car.
Okay.
And it's the same body and same unibody, but a different motor in the Geo. So I saw this on a used car lot, and the Swifts came in a GT or GTI model with some extra air, little body kit on it, and some other better motor. So I bought the car then off the used dealership lot, and just started refinishing it because I liked, kind of grew up with this car.
And nostalgic.
Yeah, a little. Well, no, I mean that was back when I was still young. So it was the Geo. I inherited it because it was gonna die soon because it was my dad's commuter car. So I needed something that I was going to start driving after that. So I bought the Swift and started just tearing it apart and refinishing everything. I was originally into stereos and and sort of the cruising scene back early 2000s. So that's kind of where I started with the car. But it's just, I think in every version of the car, it's always gone farther than I expected it to. When I started taking it apart, I thought it would just be a quick little fix-up, but I ended up down to the absolute bare shell, putting on a rotisserie, like scraping everything off the bottom. Like, it just kind of became farther and farther. And at one point, I thought, there's no way this car is ever even going to go back together and like be on the road. But it did.
How long ago was that?
That was I bought the car in 2001, I think. Yeah.
So here we are 17 years later.
Yep.
And
Many versions later as well. So it ended up being a little bit, as I modified it, more and more race parts started to go on it as the trend sort of went more towards racing instead of cruising, and became difficult to license it and e-test and all that stuff. So the car actually sat for a while, and it wasn't until I started getting into racing that there was another whole momentum swing and a lot of enthusiasm to get back working on the car. And that's just the evolution of it. Went from a built Swift motor all the way up to now a supercharged K20.
Well, maybe you can walk us through some of the custom parts or some of the little intricacies of the vehicle that maybe we don't know about.
There's literally probably nothing left on it that's untouched. So if we start up front, we've got a custom splitter that I've done now. So it's got integrated diffusers and end plates and a center channel. This body kit was something that I imported from Australia because Swifts are quite popular in Australia.
Oh, okay.
This version. So it's an imported body kit that's kind of stuck with the car. So that was the bumper, side skirts, and rear bumper. So then just kind of moving through the car, we've got a Vibrant intercooler and all Vibrant fabrication components. So all the intercooler piping and couplers and stuff is all Vibrant. CNR radiator that came off another buddy's old Time Attack car. So a lot of stuff. The fab work was done by Eric Levine, who did James Houghton's car, which is a pretty prominent Time Attack car in North America.
No idea who that is.
Yep. So, yeah.
That was a joke.
So, this is actually his old Rotrex that was on it.
Oh, really?
Yeah. So this is the Rotrex that was on James's car when it was supercharged. So that kind of got trickled down the line, and we use the same engine builder, Eric Levine, for motor work and some of our fab work. So it was built at the same shop. In terms of the supercharger conversion, the motor is a K20 Z3 with a bunch of K-tuned goodies added to it. Throttle body, fuel rail, lines. K-tune's amazing for what they've done with just innovating all their adapter plates and solutions for problems when you become a racer and want to get rid of OEM stuff and get rid of weight, and just they've really thought through a lot of stuff. One of the newest things is actually this valve cover that has four already tapped in
just
vent lines.
inlets.
Inlets. So that accepts a -10 AN. There's 2 on the back, 2 on the front. So whatever you want to do for configuring that. So I'm running that just to my catch can. But that's just an example of a lot of stuff that they do that just makes life a lot easier. And it was a big reason why I went to a K and went to the Honda power plant, was just because getting away from the Suzuki stuff, it was all custom, one-off, expensive, took a long time to get parts, not much development. I was doing it all myself. So now with a lot of the support for the K motor, it's so much easier to make power, to make reliable power, to just have a lot more knowledge base behind what's motivating your car.
Now, some of the things that we can't see, is there any custom suspension geometry work or anything?
Yep. So all of it's basically, like I said, none of it's been untouched. So the control arms that are currently on it are modified OEM control arms, that 1.5 inches wider.
Got more static camber because it's a max strut.
More, basically just mostly for track width.
Okay.
And then we've got our top camber plates for static camber. We ran a beefier, heavy top. We modified the strut top so that we could have more travel because of the ride height that we're running. So that's now mounted on top with bracing underneath, just to give us more range. bump steer corrected, roll center corrected. NV Auto actually in Hamilton is making us a nice new custom tubular control arm. So we were actually, first day out with the supercharger, we sheared one of the main locating pins on the OE control arm. So as you increase power and increase grip, and everything has to move along with that. So that being said, when we first went to the bigger power, we were just roasting the brakes that we had on it. So Neo Motorsports was awesome about bringing in, doing up a custom adapter bracket so that we can run their big brake kit with, we're on a 6-piston, their 301 caliper with aluminum hat and full, like a 3-piece rotor, it's or 2-piece rotor. It's an awesome setup. So
awesome.
It makes it a lot more comforting when you're, getting high top speeds. And
well, again, man, we're very impressed with this build. That's why we had to come back and see this. As you guys can see, there's a lot of Speed Academy logos on this. Our friends out there at Speed Academy have done a lot of in-depth follow-up on this build. So if you want to learn more about this car, definitely make sure you check them out and you can really get a look at how this thing came together. And you can even see some of the guys from Speed Academy testing this on track, right?
Yeah, we just shot they just released a video a couple weeks ago, the first video with the supercharger. And I don't think I've ever seen Dave as frightened. He literally swore to himself when he finally got on it. And he was just like, oh, it's quite an animal.
Well, folks, that's the end of our PRI coverage. We're getting ready to hop on our plane back to Los Angeles. Hope you guys liked the coverage. Mike, any last final words?
I'm looking forward to being warm. What about you?
Exactly, man. I still got this hoodie on and it was too cold outside. So be sure to subscribe if you liked the video. Sound off in the comments, and we'll see you guys soon.
And I got a shout out to Bart at Pegasus. I'm finally wearing your shirt.